All right, guys, we are back at it, and we are going to be looking at average rate of change with nonlinear graphs. And this is really great to see this because it shows you on a quadratic that the slope is not constant on the quadratic, okay? So when you find the average rate of change, you are finding the rate at which is how fast the function's y values, which are your outputs, are changing as compared to the function's x values. So you're looking at how quick your y values are changing when you change your x value, okay? That's really what it is. So if you look between these 2 points, between these 2 points right here, I only have an average rate of change of 1, okay? But then when I go to the next 2 points, so when I go to the next 2 points, I'm changing a lot quicker. You see that? Okay, between these 2 points, I have a slope of 3. All right, so it's not constant. And if I did 2 more points, it's going to have an even more dramatic change. Okay, so it really just depends on which 2 x values. So it's so important you look at the x values that I give you or the question is asking because it's going to change depending on your points. Okay, all right, so let's do some graph examples. Okay. Oh, what you doing? What you doing? I'm just going to stop. Okay. We got it. We're good. Oh, happy Wednesday. So, the function g of x is shown in the graph at the right. I want to find the average rate of change over this interval. This graphs are better because you don't even have to you really don't have to plug in anything. Okay, you're just finding the y value given the x value. Okay, kind of like we did with the piecewise functions. So our formula is y2 minus y1 over x2 minus x1. I'm really digging these colors on this color scheme right here. So my x values are 1 and 4. So I'm going to say 1 minus 4. Okay, so I need to find 1's pair. Well, 1 is right here, right? So when x is 1, what's y? 1. Okay? Minus, when x is 4, is right here. When x is 4, what's y? 2. How easy was that? No math involved, okay? Well, it's math, but not y'all's math that y'all call. So, I simplify the numerator. 1 minus 2 is going to be negative 1. 1 minus 4 is going to be negative 3. I can't reduce it down, but those negatives cancel out, right? And I get my slope to be, or my average rate of change to be 1/3, okay? So it's not always nice, pretty, reduced numbers, okay? It's okay to get a fraction, but remember it needs to be in fraction form, not decimal form, okay? So my average rate of change for this square root graph is going to be 1/3, okay? All right, here we go. Let's look at this graph. So you might have seen this graph maybe in just a picture. This is a polynomial graph, okay? And we're going to talk about this graph in later units. But right now we're just going to, you still can read it the same way you've read all your other graphs, okay? All right, so here are my x values. Okay, so we're still going to use that formula, y2 minus y1 over x2 minus x1, okay? My x values are given. It's negative 6 and negative 5, okay? So now I need to find their coparts, their y value, okay? So at negative 6, which is right here, okay, see this is negative 6. What is the y value? Let's scoot on over, and it's 8, okay? Now let's look at negative 5. Negative 5 is right here. Its y value is 4. So 8 minus 4 is 4. Negative 6 minus 5, negative 5, sorry, is negative 1. 4 divided by negative 1 is negative 4. And that is your average rate of change. Okay? So on this, so now we're going to go look at the delta math you're going to do that relates to this video, okay? And it's just more examples of graphs, okay? But I just want to make sure we're good. So let's go to the delta math assignment. Okay, we're going to go back. We're going to look at the graph one. All right, here we go. So see, it's the same thing that we just did, all right? But let's do 2 of these. Okay, if I can get it to snip for me. All right, that's not my snip. Let's exit that. You didn't snip. Oh, okay. Laptop's dying. All right, here we go. I guess since it was dying, it means it couldn't snip. All right, let's try that again. Snip. There we go. It's probably too early for it, you know? We all have those days. Oh, it snipped it twice, guys. We don't need all that. We just want to do it once. There we go. All right, here we go. So, same concept that we just did in the PowerPoint, okay? Have you ever noticed it's so difficult for me to choose colors? So, here are my x values, okay? So, we got the nice, awesome formula, y2 minus y1 over x2 minus x1. My x's are the interval, so it is 4 minus 6. Now I need to find the y values. So when x is 4, that's right here, this dot right here, what is the y value? It is 10. See how important it is to look at that scale? Because some of you would have thought it was 2, but it wasn't. It's 10. Okay? That's why I want you to stick to the formula instead of doing the rise over the run for the graph like you do with linear, because sometimes it's scaled differently and then you've got curves and then it's just so much easier to do the formula. Okay? And it's all about, I think it's better when you keep the same steps. Okay? So minus, now we're going to look at 6. When x is 6, what's my y value? 15. So 10 minus 15 is going to be negative 5. 4 minus 6 is going to be negative 2. So this is going to be 5 over 2. All right? So come over here. We come to our answer. And when you're doing fractions, let's see here. When you're doing fractions, just hit the division button. You're going to say 5 divided by, see how it creates it for you? Okay, 2. All right. So we hit submit. Fingers crossed. Yes. We got it right, guys. All right. So, see, it's showing you right there. But that is just, to me, that would be more difficult. But you can see that it rose 5, okay, and then ran 2. Okay, so you can see that. So if you guys want to do that, that's cool. I'm going to stick to the formula, okay? But Delta Math does show you right there that you can do the rise over the run, all right? All right, so let's do one more problem. So what I want you to do is I want you to pause the video and try this one out on your own, okay? All right, so welcome back. I hope you tried it. So now let's do this problem, okay? So here are my x values. We got the y2 minus y1 over x2 minus x1. I know y'all see me writing the equation over and over again. And I learned in high school from a teacher that if you always start your problem off with your formula, you're writing it so much that you're going to memorize it. Okay, so if you don't have this formula memorized, I suggest when you're doing your work, write it out in step 1. Okay, and if you keep writing it over and over again, it's going to become memory. Okay, all right, so that's my little tidbit. So we're going to say 1 minus 2. Okay, so when x is 1, which is right here, we got to go down to get this one, it is negative 15. So then I go to 2. When x is 2, y is negative 10. All right? So negative 15 minus negative 10 is going to give me negative 5 over 1 minus 2, which is negative 1. Well, negative 5 divided by negative 1 is 5. So I go back to Delta Math. I type in 5, and we are correct. So that's it for me for graphs, okay? So now go to Delta Math and do those graph problems, okay? And then we'll come back together and we'll talk about some tables.